Okay, so let's jump right in. It's kind of wild to think about, but it turns out there are just three simple rules, figured out centuries ago, that pretty much run the show. They're behind almost all the motion we see every single day. From, dropping your keys to launching a rocket, these laws are basically the universe's operating system.
Yeah, it really does sound like the start of a bad joke, doesn't it? A rocket launch, a car crash, and that classic magician's tablecloth trick. What on earth could they have in common? They seem like they're from totally different worlds. But stick with me because by the end of this, you're going to see they're all following the exact same playbook.
All right, so let's kick things off with rule number 1. I like to call this one the law of laziness. Seriously, it's basically the default setting for, well, everything in the universe. And it's a feeling I think we can all get behind.
Okay, so here's the official textbook definition. And yeah, it sounds a little stuffy, I know. But don't let the fancy words fool you. The main idea here is super simple. This is just what stuff does naturally, when you just leave it alone.
Let's break that down. In plain English, an object is just going to keep doing whatever it's already doing. Simple as that. If it's just sitting there, it's going to keep sitting there. If it's moving, it's going to keep moving in a perfectly straight line at the same speed forever. That's the default, the status quo.
And this resistance to change, this sort of cosmic stubbornness, it actually has a name. It's called inertia. And here's the key. The more stuff an object is made of, the more mass it has, the more inertia it's got. That means it's that much harder to convince it to do something different.
So, okay, this might sound a little abstract, but it has some very real-world consequences. For instance, why do you have to wear a seatbelt? I mean, why is it so important? Well, the answer is 100% because of this first law.
Think about it. You're cruising down the road. The car is moving, and you're moving right along with it at the exact same speed. Now, if the driver slams on the brakes, the car has a force acting on it, the brakes pads squeezing the wheels. But you? Nothing's stopping you yet. Your body's inertia just wants to keep right on moving forward, which is, not great news for the dashboard. That seatbelt, that's the external force that stops you and keeps you safe. It's inertia in action.
Okay, so if inertia is the universe's default don't bother me mode, how do we actually change things, all right? How do you get something to speed up or slow down or take a corner? Well, that brings us to Newton's second law. This is the one that gives us the actual recipe for making a change happen.
I mean, it's easy enough to say, oh, you just need to push it. But physics is all about the details. How much of a push, how much of a pull does it really take to get something moving? Thankfully, Newton didn't just leave us hanging. He gave us the exact formula.
And here it is, one of the most famous equations in all of science. F equals m times a. Force equals mass times acceleration. This beautiful, simple formula tells you exactly how an object is going to behave. It connects the force you apply and the mass of the object to the change in motion you're going to get. And honestly, I can't overstate how huge this is. This isn't just some boring equation for a physics test. This thing is a predictive powerhouse. For the first time in history, this little formula took the universe from being this big, scary, mysterious place to something that was, well, predictable, almost like a giant clock. If you knew the forces, you could predict the future. It's the link between cause and effect.
Okay, let's throw a number out there. 7,200 newtons. Now, a newton is just the unit scientists use for force. Think of it like a pound or a kilogram, but specifically for a push or a pull. So, 7,200 newtons. What does a number like that even mean in the real world?
Well, that's the force you'd need to take an average car, we're talking about 1,600 kilograms, and get it accelerating at a pretty good clip, about 4.5 meters per second. See? That's how you go from an abstract formula on a page to a real, concrete number you can use. That's the power of the second law.
All right, so we've got two laws down. Law 1, things are lazy and like to keep doing what they're doing. Law 2, here's the recipe to make them move. But there's one more crucial piece to this puzzle, and it's that forces are never lonely. They always come in pairs. This is what I call the law of cosmic pushback.
You've almost certainly heard this one before. It's probably the most famous of the three, and for a really good reason. It points to this beautiful, deep symmetry in how the universe works. At its core, it's simple. You can't touch anything without it touching you right back.
And here's the man himself, Isaac Newton, in his own words. The really key things to catch here are mutual actions and two bodies. This is so important. The forces are always equal, they're always in opposite directions, and, this is the part people forget, they act on different things.
This is where a lot of people get tripped up, so let's make it crystal clear with an example. A swimmer pushes backward on the water, that's the action. The reaction is the water pushing forward on the swimmer. See? Two forces, acting on two different things, the water and the swimmer. That imbalance on the swimmer is what actually propels them forward.
And once you see it everywhere. A fish pushing water back to swim forward. A bird pushing air down to fly up. And, yep, a massive rocket pushing hot gas down with incredible force to launch itself up into space. It's all the same principle. To move one way, you've got to push something else the other way.
But now for the really wild part. Okay, get ready for this. We all know the Earth is pulling you down with gravity, right? That's what keeps you on the ground. Well, at this very moment, you are pulling the Earth up with the exact same amount of force. The only reason the entire planet doesn't come flying up to meet you is because its mass, its inertia, is just unbelievably huge compared to yours. But the forces, they're identical. Kind of changes how you see things, doesn't it?
Okay, so there you have it, the big three. Law 1, objects are lazy. Law 2, here's the recipe to make them move. And Law 3, every push has a pushback. They're simple on their own, but the real magic is how they all work together as a team.
Well, okay, I know a diagram like this can look pretty scary, with all the arrows and angles. Don't worry about the math. Just look at the idea. This is what physicists do. They take a situation, like a block sliding down a ramp, and they use Newton's laws as a toolkit. They say, okay, where's the gravity? Where's the friction? What's the ramp doing? And then they plug it all into F equals ma to figure out exactly what's going to happen. And it's the exact same story for something that looks even crazier, like this whole mess of pulleys and ropes. Again, forget the details. The amazing part is that you use the same three simple laws over and over again for each piece of the puzzle, and suddenly you can predict how the whole system will move. It's how we turn what looks like total chaos into something orderly and solvable.
So here's the bottom line. These aren't just three random facts to memorize. They are a complete, interconnected system, a framework for understanding, well, everything that moves. This is the stuff that explains why planets stay in orbit, and it's also why that magician can yank a tablecloth out from under a pile of dishes without breaking them. It all comes back to these rules.
And that brings us right back to the beginning. The rocket launch, that's all about action and reaction. The car crash, a terrifying lesson in inertia. The magic trick, a clever game played with that very same inertia. They all obey the same rules. So the real question for you is, now that you know the rules, where else do you see them? What parts of your everyday life are secretly being governed by these three powerful laws?